Hey everyone, welcome to the video. In this video we'll be going over std-thread, the basics of it and some small examples. So let's get started. What I have here is a very simple example of creating a thread in C++. Here I'm creating a thread called thread, and as part of the initialization I'm passing it a worker, which is nothing but a function which takes in nothing and returns nothing. What needs to be passed to the constructor of std-thread is a simple function pointer. You cannot create an std-thread object without passing in this function pointer, because this class follows the RAII pattern, which I've talked about in one of my previous videos. There is an important twist though here. The owner of the thread object is responsible for explicitly releasing the resource before the destructor of std-thread runs. Otherwise, the program will wrongly terminate. In other words, crash. We take care of the resource by calling in join or detach on the original thread object. As soon as I create this thread object over here, new thread gets kicked off instantly without any kind of delays. Now you release this resource by either calling join or detach. If you fail to call join or detach, in other words, you don't take care of the thread resource, it is going to abruptly crash your application. Let's see how this application runs as of now, and we'll see what will happen if we forget to call this join. If I run this, we get hello from main and hello from worker. Nice. Let's see what happens when we call detach instead of join. If I run this, we get the same exact behavior. The only difference being, if you use join, the application is going to wait for the termination of this thread, and in detach, the application would terminate even though the thread is going on with its execution. It will kill it abruptly, but still your application would quit gracefully. Now what would happen if I remove the thread.join call? If I forget to call it, let's see what happens. This is the application crashing. As you can see, debug error. Abort has been called. Press retry to debug the application. We'll click abort. Now as this thread constructor takes in just a function pointer, we can simply pass it a lambda function instead. Can do so by doing this. If I just copy and paste the entire content of this worker function, let's resume joining the thread, build and run this, we get the same output. Let's get back to the initial state where we were before adding in this lambda. Resume the thread.join, and let's discuss an important thing over here. So what if your function took in some additional parameters and processed it maybe inside and then printed out to the console or do whatever? You can take in the extra parameter like this. I'm taking in an int, maybe just print it. Now you can process that extra parameter, but you need to provide that extra parameter while you invoke your thread or create your thread. You can do so by providing in the argument once you have specified in the function pointer. You can do so like this. Here I'm passing 10 for x. Any additional parameters, let's suppose y, you can provide it in the same fashion. Now if I print both x and y and run this, you see hello from main and hello from worker 10, y 20. To pass values by reference, you can also do so by wrapping them in something known as stdref and passing it like this. I'll just change this to be an int reference. Obviously I need to change this to the variable name, and now if I run this, we get the same result. Just to prove that we are indeed taking in the reference, we can maybe increment the value of x by, let's say, 10 and print it out once again in the main thread. If I run this, you see hello from main, x is 10 and hello from worker 20, y 20. Well, what did just happen? We inspected the value of x before we actually waited for the thread to join. So here is a data race. What is happening is that x is getting incremented after we print out the value of x in the main thread. If I just move this underneath this line, we should be getting x as 20 and it would be printing after we print hello from worker. Let's verify that by running the application. And now you can see X is getting printed as 20 and it is getting printed after hello from worker. Sweet. I've cleaned this up a bit. Now let's see how we can pass in values while using lambdas instead of function pointers. So let's specify a lambda. We'll take in a value and print it. Simply print it as it is. X is not identified, we need to take in as the parameter of this lambda, and we need to provide the value of X over here. We'll obviously wait for the thread to complete. Let's run this. As you can see, we get X is 10. To achieve the same behavior of passing in X as a reference and then modifying it inside the lambda, you need to do something with the captures of this lambda. You need to provide ampersand to indicate to the lambda that we are going to be taking in values from the outer scope with reference. You can get rid of this line, and now we can use X directly as it is declared over here as 10. It's using the same exact variable X. There is no change in the memory address, and we can increment the value by 10, and then after we join the thread we can print the value in main. Let's build and run this. Okay, we get some errors. We need to get rid of this. This should be good to go. Let's run this again. And as you can see, X20, and from main, X is again 20. So we indeed modified the variable X, which was owned by main and not this thread. If your lambda took in multiple arguments, you can do so. You simply provide maybe a multiplier, and we can pass that value of multiplier over here. So after this lambda declaration or the function pointer to the thread has gone, we provide the variable which needs to be going into the parameter of the worker or the function pointer for the thread in this case. What we should expect is that X will be incremented by 10. It's originally 10 and it's getting passed in via reference, so it will become 20, and the actual value in the main stack frame will also be 20. 20 will be multiplied with 2 and printed. Well, no multiplying action would actually happen unless I do this. Now we are making use of this multiplier argument, and we are multiplying this value X, which has been incremented by 10. 20 into 2, 40. We should expect to see 40 over here, while the main, it's still going to be 20. Let's run this and verify. As expected, X is 40 and inside main X is 20. Now you can also provide callable instances, or in other words functors, to threads. So here I'm creating a sample functor and I'll be overriding the operator parentheses or the function call operator like this. And we simply print hello from functor. Let me clear all this. We create a functor object, we create a thread, and now we can pass in this functor object to it, since this is a callable. So you can either provide functions, function pointers, or you can provide lambdas, or you can provide functors, because all of these are essentially callables. And since you're providing in function pointers and lambdas, so you can also provide std function objects as well. Let me print hello from main to indicate that we are in the main execution block. Here I'll wait for the thread to complete. So this right here is another way you can use to create threads. Well, that's all for this video. We covered the basics of how to create threads. In the future, I'll be showing you different other ways to deal with multithreading and asynchronicity in your C++ applications, going from writing just a single line of code to offload a bulky task to a bunch of auto-spawned threads, to how you can create your own thread pool where you can reuse a bunch of threads for different varieties of tasks, which can maybe simply be downloading multiple images of the internet for your deep learning model to train on, or loading multiple meshes for your game engine to process, or in an asynchronous server application where you have to accept multiple different simultaneous client connections ensuring every client receives the same and optimal performance while avoiding starvation for them. So stick around the channel for all of this awesome content. I hope you like this video and I'll see you in the next video. Bye.